Okay, Math 9s, welcome back. In this video we'll look at, again, the surface area of some other composite objects. We'll also look at how to use Pythagorean Theorem to find some information within an equilateral triangle. Okay, so our focus, again, determine the surface area of composite objects. Okay, so a reminder, what I like to call the useful tool alert. A reminder that Pythagorean Theorem is just a squared plus b squared equals c squared. There's that picture again, we've seen that in a previous video. And how we can use that is to, in this example, is to find the length of the missing side. So if we think of calling that x, our steps again are to write down our Pythagorean Theorem. We'll identify which side is our hypotenuse, and then we'll plug in some numbers. We know that the hypotenuse, which is directly across from your 90-degree sine, our hypotenuse has to be this c, or the number that's by itself. Okay, this becomes 15 squared and 8 squared. Okay, and if we work through the math of this, we end up with x squared is equal to 289. And if we do that opposite operation to the squared, opposite to the squared is the square root. If we do the square root of 289, we get that side length as 17. Okay, and then I just asked myself, hey, does that make sense? Should that be 17? Well, it's got to be the longest side. It's the hypotenuse. So yeah, it fits for this triangle. Okay, so how we can apply that to a question like at the bottom of your page here is, what if the triangle is not a right triangle and we need to know its area? Okay, so how we can do that with within this triangle is, well, first of all, we need to recognize that these lines that are on the sides, those lines just tell us that, hey, each side is exactly the same length. So we call this an equilateral triangle. That's a triangle that has each side is the same. So if a tool that we can do is we can split this triangle in half, and if we split this triangle in half, then this bottom is going to be 4 and 4 with a right angle at the bottom. So, and what we're really driving towards, looking to find, is this height, because when we're looking to find the area of a triangle, we need 1/2 base times height. So we need that height value. Okay, so if we're using Pythagorean Theorem, we can think of just splitting this triangle into its two parts. We would have the hypotenuse is 8, the base would be 4, and then we'd be looking for the side, so we'll call this x. Actually, sorry, let me back up. We should call that h because we just labeled that in our triangle as h. Okay, so our starting point is a squared plus b squared equals c squared. Our hypotenuse is 8, so that has to go on the side by itself. The legs, or the other two numbers, we can fill in. Then if we do the 4 squared and the 8 squared, we have to do a little bit of algebra just to move this 16 over to the other side. Then we'll take the square root. To find just h, and h is going to be 6.93. Does that make sense for this triangle, that this is 6.93? Yeah, it looks reasonable anyways. It has to be shorter than 8. And then the whole purpose of finding that is because we wanted to find the area of this triangle. So the area of a triangle is base times height divided by 2. Our base of the entire triangle, oops, I meant to highlight that. Base of that entire triangle is 8. Our height is what we just found, 6.93. Put brackets around that so we don't confuse the dot for multiplication and the decimal point. And then divide it by 2. If we do that math, get the area of the circle is approximately equal to 27.7 units squared. Let's get rid of this thing, because yeah, that's what I thought. This is not units, we're actually given units of meters, so let's put correct units in there. 27.7 meters squared. Okay, the backside looks at a pretty complicated example where We've got a lot of different shapes going on. We've got a triangular prism, a couple of cylinders, a rectangular prism. So let's go and read this question. Let's read it carefully because it's going to help us figure out what we need to find here. Okay, so in this question we have the roof, columns, and base of this porch are to be painted. Okay, so the columns are these cylinders. The porch is attached to a house, so you will not paint the backside. That's going to be key to remember. The radius of each column is 20 centimeters. I'm just going to go and highlight some key info. What is the area to be painted? We're looking for what is the area to be painted to the nearest square meter. Okay, so the first thing that we'll do is we're looking to the nearest square meter. So I just noticed down here that we've got a measurement that's in centimeters. So the first thing I'm going to do is I'm going to convert that into meters to make sure that our units are all the same. So 15 centimeters is equal to 0.15 meters. So the next thing I'm going to do, I'm going to scroll down here just to give us more room. So the next thing I'm going to do is find, similar to what we just did on the front side, I'm going to find the height of this triangle by splitting it in two, and our dimension for the slant height is 2.0 meters. That comes from back here. We can look at, hey, that's going to be 2.0 meters. If we split it in half, this is going to be 1, and then we can find the height of this triangle. So that's going to be a squared plus b squared equals c squared. 2 is our c, and then our other values are like so. Okay, we can go through this and say, hey, that's 1 plus h squared equals 4. H squared is equal to 3, and then h is equal to the square root of 3. So I'm just going to leave this as h is the square root of 3. Okay, so I don't know, I'm going to come up here and just start thinking about, hey, these different sides. So I'm going to call that triangle side A because we just found the height. So we might as well go and find the area of that, which is base times height divided by 2. Our base is going to be that 2 meters. Our height is what we just found, divided by 2. We know so we can do a little reducing here, and we're just left with the area of that front triangle is square root of 3, or 1.73. I should put a little approximately equal to sign. We'll need that later, so we'll put a circle around it. Okay, if you look at the roof then, I'm going to call this B, and there'll be 2 of these because there's another rectangle on the back that will have the same dimensions, and those dimensions will be, it's a rectangle of dimensions 2 by 2.2, and then there are 2 of them, so I'm going to multiply this whole thing by 2. Okay, so 2 times 2.2 times 2 should be 8.8. Again, we'll leave units off until the very end. Okay, so we have the triangular prism covered. Oh, except for this bottom side of the triangular prism. Might as well find that next. Bottom side of this triangular prism is going to be a rectangle that also has dimensions of 2 by 2.2. And I guess I could have included that in the sides of the rectangle. But anyways, that's going to be 4.4. We'll need that later. Okay, so for the columns, now let's do the columns. We'll call the columns D. And for the columns, it's only we're painting this thing, so it's only the sides of the cylinders that are exposed. So this is going to be 2 pi times the radius of those things. And the radius of each column is 20 centimeters, or 0.2 meters. So this will be 2 pi times the radius times h, which is 2.5. And that's for one of them. 2 pi RH, and then because there are two of them, we'll multiply that by 2. Okay, so if we chug all that through, we should get 6.28. Okay, so we're getting there. We're getting there. Now let's maybe look at, I don't know, we can look at this top. Of the porch, and that is going to be, sorry, that's a really terrible E. Let's erase that. So we're looking at this face, E, which would be a rectangle. That dimensions will be 2.2 times 2, which is 4.4. Okay, so you'll notice we're just being very systematic, right? We're being very systematic as we go through this and just marking or checking off each side. Side F, I'm not even going to write an F, but I'll just highlight the rectangle is going to be the side of that rectangular prism on the bottom. So maybe we'll put an F here. Okay, and there are, so the dimensions of that thing will be 2.2 meters times 0.15 meters, and then times two sides. Okay, so 0.66. And then this front face, we'll call that G. We'll have dimensions of 2 times 0.15. Okay, I think that's it. Ooh, except for, I almost forgot. For the underside of this roof, for C, and also for E, we've got some overlap where these columns are. We've got 4 circles. Let me just highlight those 4 circles. That's not a very good color for highlighter for this question. We've got 4 circles that are overlapped. So we've included those in the area calculation of the rectangles of sides C and E. So we need to subtract those out. We need to subtract the ends of the cylinders. Okay, so to do that, we'll have pi r squared is the area of a circle, and there are 4 of them, so that'll be 4 times pi. The radius of one of those columns is 20 centimeters. Which would be 0.5028. So I don't know, maybe I'll just put a negative here to recognize that, hey, we need to subtract that. We need to subtract that out because it's being overlapped. Okay, so now if we go and do some math, we go and calculate, hey, what's 1.73 plus 8.8 plus 4.4 plus, we add all those numbers up. I'm not going to write that out again, and then at the end we're just going to subtract that 0.5028. Let's see what we get. Okay, so if we do that whole math, and please check it, I think we should end up with 26.07 meters squared. This is our total. Maybe we'll put a big highlighter on that. Okay, so lots going on in a question like that, but if we break it up and systematically go through the sides, that's a good method or good method to follow for solving a question like that. Okay, so again, this section's big idea is to, let's just put, we're just finding surface area of composite shapes. And our assignment to try some harder shapes will be on page 41, 6, 7, 8, 11, and 13. Okay, hope that gets you going on some tougher questions, and thanks for watching, and see you soon.